Hey everybody, my name is Chris Dorrington. I am a Principal Cloud Architect. I work in professional services, which means I work very closely with our customers, particularly in SaaS transformations and SaaS projects. But today I'm going to be talking about some multi-tenant patterns and strategies that you can employ in your application, in your SaaS applications, when we're building in generative AI. But it might be obvious why we're talking about SaaS and generative AI, but I want to cover a few things off. The SaaS is a business model that's been around for a couple of decades. There's no stopping it. There's more and more companies going to it. But we've had generative AI that's come along like a juggernaut, and in the last year, everyone's trying to build that into their applications. Their SaaS applications, everyone's looking for that killer feature. How can we get generative AI into our product and make it different to our competitors, and ultimately better for our customers? And talking about customers at the end of that is how do we differentiate that generative AI experience depending on the tenants that are using our products? And this is really what I'm going to be focusing on today. Like, how do we actually come up with something different and we're not just having the same experience for different domains and different tenants in our multi-tenant application? I'm also going to be talking about ways that you do tiering and packaging. And I'm sure most of you in here are builders, and you might be thinking that's just the product and marketing team down the line. But I will actually be talking today, and you'll see how the way that we deploy and use our generative AI services is going to affect the tiering and the pricing. So we have a lot of control over that as builders. Now, if you've been following the SaaS story, to be a successful SaaS provider, you need to be able to scale your customers without scaling your operations team. So that means on the inside of the business, you want to be able to run with a lean team and have a unified operational experience and get really good business insights and tenant-aware metrics. Now, I'm not going to dive too much into this today, but I do want to call out that everyone's focusing on how generative AI can help the end customers, but it's definitely a space that's evolving in about how you run your business. So your developers and your operations team and your business analysts on the inside can really benefit from how generative AI is going to change the way that you provide your service. And also, in the SaaS world, we talk about time to value. So that's where your customers want to use a product to being able to use it, okay? And this is called the onboarding process. We like to say frictionless onboarding. So how can we make that as smooth as possible? How can we make this process as smooth as possible? And generative AI definitely has a space to play in here. How can we help the customers get onto our systems faster and start using it and then getting value from it? So just a few things I wanted to highlight there about why we're talking about SaaS and generative AI. But I will be focusing on how we differentiate those tenant experiences. But first, just want to set the table. What are the layers in a SaaS multi-tenant application where we have generative AI? Well, at the heart of it, we have these large language models, these foundation models that you'll all have heard about. These are actually very costly and complex, and companies don't tend to make their own. So we use third-party providers, and you'll recognize all the names up there. But we can't use these directly, okay? We need some sort of APIs on top of it. So we have from Amazon, we have Amazon SageMaker, and we have Amazon Bedrock. These literally give us the APIs to interact with the foundation models underneath. You'll see on my next slide, we can absolutely create a application that just interfaces straight into these APIs. But because it's a stateless service, we're not going to be able to give a differentiated experience to one set of customers against another set of customers. So how do we do that? Well, there's a few options available. We have fine-tuning. You might have heard of this. This is where we can get a foundation model, and we have some more training data, and we basically retrain that model and bake in some more information that's specific for our needs. So we get a copy of the foundation model, and that's what we use from then on. We also have retrieval augmented generation. Now, you'll have heard of this. We talked about it in the keynote. This is literally where we have the query that's coming in from the user, and before it gets to the foundation model at the back end, we augment that prompt with more contextual information, and then we can generate the response, and it gives a much more accurate response. I'll be diving into that into a bit of detail in the next few slides as well. State and memory is where we want to store away some conversational history, so you might be remembering what was said last time you interacted with the foundation models, because remember at the base, they're all stateless. They're not going to remember. So every time that we interact with it, we need to provide it the same information. And on top of this, of course, we have our SaaS application. Okay, a multi-tenant application where we've got to be thinking about data partitioning, tenant isolation, a SaaS identity. All of these things still come into play. And you'll notice that I haven't really aligned the boxes here because you can kind of choose your own adventure. And as we'll explore as we go through this talk, there's some different options and why you want to use these different services. So the simplest generative AI experience you can have, as I mentioned, is just to interact with the APIs on Amazon Bedrock, choosing a foundation model at the back end. We could absolutely build a single page app that uses this, but as I mentioned, it's stateless, it's not going to remember, and it's not going to be tailored to a different set of customers. So if you have some customers, maybe in the banking industry or versus the healthcare industry, your experience is going to be the same. We're going to be using whatever the training data that was baked into that large language model at the back end. So we want to change that, right? So I mentioned those few different things that we could have earlier. Let's dive into RAG. So now, let's just imagine that we're an e-commerce platform, okay? So our product as SaaS is providing a platform where customers can sign up and then they can sell their products. And we maybe got a set of golf stores and hardware stores and a retail chain. They're all using our product. But when the requests come through, and maybe they've got a chatbot that helps them choose and purchase products, it's going to have a particular context, right? We need to know if we want to differentiate that it's coming from the golf stores. It's a user who's using the golf stores. They might be saying, you know, I'm a left-handed golfer, I'm only a beginner, you know, what golf clubs have you got for me, okay? So we want to tailor that. And probably the large language model might not have all the information about our latest products, and maybe not even for left-handed golfers. So what we want to do is augment the prompt before it gets to the foundation model. So we go off, and maybe we get the list of all the products that we have, and maybe any other information, get that together, and now the query that's going to the back end is much bigger. It's got all this contextual information that allows that large language model to give you a much more accurate response that's specific for our golf stores. And the same for the hardware stores, and the same for the retail stores. We can differentiate here. Just double clicking on that, you know, this is where we then start to think about, well, we have to store that data somewhere. And this is where the common terminology in SaaS, where we've got pooled tenant data. For cost efficiencies, we might choose to store multiple tenants' data in the same data store, so it's kind of commingled. Or we might be using siloed data stores, and so it's just dedicated to there. So you can start to see now, like we've got the generative AI thing, but suddenly now we're coming back to how we're storing our data and how we're going to isolate our data. These are the things that I'm going to explore a bit more. So, RAG data sources can actually be from anywhere, but the most common are vector databases. And the reason for this is because you can do semantic searching with vector databases. And remember here, when the RAG is activated, we want to go and retrieve some contextual information. So when we're doing semantic searching, we can pass the query in and it will find the information that's close to it, and then give that back, and then we can pass that on to the language model. So we've got Amazon Aurora, a Postgres with the PG Vector plugin, or OpenSearch Serverless with the K&N plugin, but you've got Enterprise Redis, MongoDB. They're all providing vector search capabilities now. But we might use other services. We might use Kendra. We've gone through all our documents in our system, or we might actually be proposing products to purchase based on past purchase history with Amazon Personalized. But with all these things, you've got to come back to the basics about how we're going to be isolating that data and how we're going to partition it, and importantly, this concept of noisy neighbor in the SaaS world, which is where one tenant can be using a service so much that actually affects the experience of another tenant. So, setting up RAG, if you didn't have services to help you, is a bit of an ETL type job, okay? We've got to get our source data into a vector searchable database. I'll use vector database as an example because that's the most common. And you'd have to chunk it up. So we released in reInvent last year knowledge bases for Amazon Bedrock, which makes this process really easy. And I'll walk through this now. And I'll explain why this is useful for creating that differentiated tenant experience. Let's say we're the golf stores, right? We need all that information. There might be PDFs, CSVs, all our product lists. We've all got that stored in an S3 bucket. But we need it to be contextually searchable, so we need to get it into a vector database. And a really good one is the serverless version of Amazon OpenSearch. When it's stored in there, it needs to be in a numerical format. That's called embeddings. But we need to get it from A to B. And this is where we use knowledge bases. We set up knowledge base, we point it to our bucket, and it then uses a large language model called Titan Embeddings to actually chunk up that data and convert it to this numerical format, which is called embeddings. So it puts it into the OpenSearch serverless domain there. Then what we have, knowledge base will actually give you back a specific API. Now, if you ever want to interact with the foundational model at the back end using RAG, you've got an API that you call, that you pass your query in, and it will do that whole RAG process. So this is really good. So now you can start to see we can have a knowledge base for each one of our types of tenants that we've got, for the clothing store, for the hardware store, and for the golf stores. But this is really good for relatively static training data. You know, as I said, like you might want all the manuals and everything else that you got for all your tools in your hardware store, put all that in there. And you can absolutely run this process as often as you want, but it's going to give you that contextual information, but it's not so dynamic. So let's imagine now, like we've got the ability for somebody to say, hey, you know, what type of golf club do I need? But now you tell them which one they're going to need. They want to go and purchase it, right? So this is much more dynamic. So we need to actually give that capability. And we've got agents for Amazon Bedrock which can do that, these dynamic actions. And effectively, what's happening is when you're going to say, I want to purchase this set of golf clubs, it's a task, right? And actually, foundation models are good at breaking down tasks into a sequence of steps. And agents, what we can do with agents for Bedrock is actually tie those steps to some APIs at the back end, and we can actually process it. So when we purchase, we might need to get the shipping charges, we might need to create an invoice and actually trigger off at the warehouse the delivery. They're kind of dynamic steps, right? So how does that work? So we have the task that comes through, we're setting up the agent for Bedrock, and with anything we do with LLMs, we need to tell it what we want it to do, how it to behave. So we're going to say, you're a retail assistant responsible for helping a customer select a set of golf clubs. So now it knows what mode it should be working in, right? It's got this task coming in, which says, I want to buy this golf club. Click. It takes it to an LLM, and it'll actually break it down into what's called a chain of thought. So it's kind of step 1 to step N, okay? In agents, you can actually associate that to some compute at the back end. You can actually put your own business logic in new lambdas, or it can be a facade to existing microservices. You can even import an open API spec of your existing APIs, and you'll be able to associate those to the specific steps. So something really cool here. And also, it might need to go and get more information. So it'll actually go off and search a knowledge base and go and get more information there. So once it's done all the steps that it thinks it needs to do, we've basically got the raw data and the task is kind of complete. But it's not really in a format that we want to send it back to the original user. So it sends it off to a foundation model again, and it processes it and puts it in a nice response, and then passes it back. So this is a really good way to tailor your experience for your customers and incorporate those dynamic sequence of actions. So that's talking about RAG and how we can have static data, and we can add in now the dynamic concepts to our tenants. But I was also talking about, there's another way of doing this as well, which is fine-tuning. So I'll just dive into that a little bit more about how we can do that. So we have our foundation models, but with fine-tuning, we're going to make a copy of it. If you remember, I said we're going to have some training data. And we might be able to get some more information that's about those tenants. Maybe it's the hardware store, as I said, all that information. We know that it's not going to change that often. So maybe we don't need to use RAG. We can actually just bake a new model. And we use that. We use fine-tuning. We fiddle with hyperparameters, which is basically the configurations of how we want to retrain. We've got some levers to pull, basically. And it will give you a model. And now we've got a model per tenant. So whenever we have a request that's coming in, say from the hardware store, we use the hardware store tenants model, which is cool. But maybe we don't need a model per tenant. Actually, we could have it per domain, like your verticals. If you have a bunch of customers that are all hospitals, and as I mentioned before, maybe you've got some banks, maybe you create domain-specific models. Run it through the fine-tuning, and now you've got some models in front of you that you can use specific for that tenant who aligns to that industry. So some thoughts there about how you can use fine-tuning as well. So another good way that we can do this. Now, they're all good, those services are good, but how do we actually fit that in, and when do we set them up? Because they take a bit of time, so we don't want to be doing that when people are actually trying to get responses from the system. Well, in the SaaS world, we have what's called a control plane. This has a bunch of cross-cutting microservices that deals with the application plane, which is actually where your product is sitting. So your generative AI application would be in the application plane. But in the control plane, it deals things like onboarding. And in the onboarding process, we have tenant provisioning. And this is traditionally where we'd be setting up things like if we needed to create an S3 bucket, or we needed to create a Route 53 domain, this is the point where we do it. So we'd be poking the application plane and say, hey, get ready for users to come in, we've got a new tenant. This is a perfect place where we can actually add in the fine tuning. So as part of the onboarding, and we've got part of the prerequisites is to actually get some data specific for those tenants. And we can use that then to create the fine-tuned model. Or we can set up the RAG data stores. So once we set up those RAG data stores, we've got either a new ARM for a model or we've got a RAG endpoint. But we're going to need to store those somewhere, so later on in our application, we know when to use it. So this is when we'd use a tenant management microservice. And this is where we can store away per tenant. So for the golf tenants, we've got a model ID and we've got a RAG endpoint. So if you imagine now, when we're actually running the application, we have a request that's coming in, and we know it's coming from the retail store domain. We actually query the tenant management and say, hey, which endpoint should I be using? We pass it back and then we use it. So now we've been able to differentiate our tenant experience because we're using the specific endpoints that we've trained up. So it nicely fits in here. So all those services are really good, right? But I would say that the hardest bit is for you to figure out how you're going to do it. Like, where are you going to get this information from? Are you going to be able to get industry-specific information? Are you going to be able to get that much tenant-specific information? This will help you choose whether you're going to use fine-tuning or whether you're going to use RAG and knowledge bases. So, although the services are there, this is probably one of the hardest pieces. And I'd say this is a paper exercise, right? Start with this and work backwards. We love working backwards at Amazon, that's what we do, but I suggest that you do it too. Like, work backwards, who are your potential tenants, and what information can we get and feed in? This will help your architecture decisions. Okay, so moving on to tenant isolation. This is one of the core SaaS concepts, right? How do you isolate tenants from each other? We do not want cross-tenant data access, right? This could be a company-ending event. And when we're building generative AI applications, I have to say, it's really cool, right? I love building these things and we get wrapped up, but we must come back to the basics about tenant isolation and how we can restrict access when one tenant is using generative AI versus the other one, okay? So I'm just going to recap a couple of fundamentals, and it might sound common sense, but it's one of those things that's easy to forget. When we use, we're in a SaaS application, typically what we have is we have a tenant context, so that says in the JWT we're able to tell which tenant is coming through. One option for being able to do tenant isolation is to use IAM roles and policies within it that restrict you just to the context of that tenant. So I have a request coming in from tenant 1, I assume a role that has a policy that only allows me to access the fine-tuned model for tenant 1. Okay, so we don't allow it to access tenant 2. So this is quite nice because the fine-tuned models are a resource level and we can definitely handle with resources in IAM policies very easily. When it comes to RAG, I call it a familiar challenge because in the SaaS world, you have to know your services that you're using because there's so many that you could choose from, okay? We've got a bunch of different things. It could be S3 buckets or open serverless. So you need to understand what that is going to give you in terms of being able to restrict tenant access. If it becomes at the resource level, we have a S3 bucket or an open search domain, that's not so bad because again, that's very easy to put into a policy. The tricky bit comes when you start to use pooled deployments. When we start to choose pooled deployments, and there's very valid reasons for using pooled data stores, you need to start thinking, well, how can I actually do that restrictions? I'll walk through a little example here and probably show you the easiest one. We have a tenant coming through, we assume that role, but this time we've got a pooled data store, okay? We need to access only that tenant's data. I'm going to show DynamoDB because it's one of the few services that actually offers item level restrictions. So there's a condition key called leading keys where you can match the partition key against the value. And here we'd have the tenant name as the value. And so we can restrict when we're in the context of tenant 1, we can only return data for tenant 1 that's in that table. Now, if you're using RDS or other data stores, you're going to have to dive a bit deeper. You might use row-level security there, but it becomes a little bit more complex. But the trade-offs are you might have a more cost-effective data store in there. On the flip side, you can go much more easily, but maybe more not as cost-effective, is to use a resource-level approach of using silo tenant data. So you store all your data in a specific data store for that tenant. So was just a bit of a recap, but just remember to be doing this, okay, as you go through. Don't be putting stars in your policy because you want to get to, get the results at the back end. You need to be thinking about how you can actually restrict access per tenant, and it still applies in the generative AI world. So, the last section I'm coming to is about tiered experiences. Now, we're on Builders Day, and as I mentioned, everyone thinks that product pricing and tiering is something down the line, but it is definitely something we need to be considering. Why is that, right? Well, I think that building and operating the system, you really need to be thinking about, and what I would be worried about is how are we going to stop tenants from affecting each other? How are we going to keep that optimal experience going to our end users of those tenants? This is the noisy neighbor situation. But also, how do we stop one tenant from chewing up all the quotas? We have quotas for different services in AWS. How do we stop one tenant from using all that quota up, and then that stops another tenant from being able to use that service? Okay, so as you start to think about this when you're designing the application, some of the ways you can do this is to deploy it differently, and I'll investigate some of that in the next couple of slides. But then it starts to lean itself towards a tiering, right? So you might offer a certain level of service to your basic tier, but you're going to restrict them to the amount of calls they can make because you don't want them to affect other users of that tier. But as you want to allow customers to use more of your service and be able to hit it faster and maybe more complex queries, you need to be thinking, how can I actually allow that, right? And that might be a different way of deployment, which leads to, it leads into tiering, right? And then therefore, you are kind of driving the different tiers, and then the product team down the road can think about how you're pricing that. One other kind of nuance with using Bedrock and generative AI is the way that it's built, right? It's not just on a rate or kind of memory consumption. It's actually on the token complexity that you're passing in and that's coming out. And for that reason, I really recommend that you actually start monitoring your cost per tenants. Even if you're not passing on the platform cost to your customer, this is a really good business insight into how your tenants are using that system. When you get your bill for Bedrock, it's not going to tell you which tenant used it. So we need to cater some way of analyzing these requests that are going in and going out. So we have the requests that are coming in, it goes through our microservices, but before it hits the foundation model at the back end, we need to be evaluating those tokens, right? Tokens is just like the number of characters and the chunks of characters. Passing that into Bedrock, but also on the way out, how complex is that answer, okay? This is also what you're going to get charged for, so you need to start thinking about that too. And in the SaaS world, in a good SaaS implementation, we have a metrics and analytics service that you can pass this data to, and we can capture that. And you can build some insights on top of that, some dashboards, you name it. But I'd still recommend doing this even if you are not using it for actual pricing purposes, okay? So little nuances there you need to be thinking about as you go through. So wrapping this up, talking about pooled versus siloed and the deployment models and the tiering, they all kind of come together. So we're talking about differentiating different experiences for our tenants, but I also mentioned, mitigating noisy neighbors. One way you could do this is to have your basic tier as a pooled model. Okay, they're all sharing the same model, and we're not adding in any customizations. This might lead on to a cheaper pricing for your basic tier. Now I'll add here, like when we're sharing a model, I need to reiterate that Amazon Bedrock is a stateless service, so any data that's coming in and any data that's generated from it doesn't exist, doesn't stay in the system. We do not use that data to retrain the models, and the third-party providers don't have access to this data either. So it's quite okay to be sharing a model, not a fine-tuned model. We don't have to fine-tune it for security reasons. So this might be your basic tier, but on the flip side, we've talked about how do we differentiate that customer experience, and we talked about RAG and fine-tuning. This is where we might actually start to have that premium tier, but deploy it in a silo architecture. Now we could actually perhaps raise the complexity of the requests going in through those tenants. Maybe in the basic model, we allow up to a certain complexity. As soon as they ask hard questions, maybe we need to bump them up a tier, right? But maybe we change the way that they're pricing as well. You could do it per token in the basic tier, but maybe it's just an annual subscription on the premium tier. So you see here, it all kind of comes together about how you're deploying it, how you want to charge for these customizations, and providing that end service that differentiates that tenant experience. Okay, that's kind of it. I just wanted to hit those few things. I'll go through the takeaways here. We want to have that awesome SaaS experience, right? And how to, in a multi-tenant application, how do we actually build that in? How do we differentiate that? Well, you can use fine-tuning and RAG to enable that. But don't build your own, right? Use the tooling that's out there. Knowledge bases is really good, and agents as well. Also, there's other tooling like LangChain. Just look out there and find out what the tooling is, because it'll make your experience a whole lot better. You don't want to be building your own ETL pipelines if there's a service that can actually do that for you. But of course, the information that you're going to need to use those services is actually going to be the hardest bit. So reiterating, start from that, work backwards. What tenants are you going to have? Profile your customers. Even if your MVP or your MVS is only going to target a certain profile, tenant profile, have a look around and expand that, that viewpoint before you get going, because it might change the way that you implement your system, whether you're using RAG or fine-tuned models. A SaaS application, we still have all these things like siloed pooled deployments and tenant isolation and noisy neighbor. We need to be thinking about these things. So as we get into the building of these products, let's not forget about that. Okay, these are fundamental. They're still part of the story. We might want to think about how we are throttling and doing the pricing, because the token complexity is affecting the back end and how you're getting charged to use the services. So have a think about that and make sure that you're actually analyzing those requests going in and going out and storing that away so you can have insights later on. And altogether, as builders, you know, those deployments and those customizations and the way that you want to have that tenant experience differentiated is going to affect the way that you do your tiering and pricing. And you as builders will have an effect on that. So that was kind of a rapid 27 minutes of this. I hope you've kind of enjoyed it. We have a bunch of skills on skillbuilder.aws. You get a 7-day pass. I've done the Amazon Bedrock ones on there. They're really good. If you want to go and figure out how to use agents and knowledge bases, this is the way to do it. We don't have time for Q&A, but you can connect with me on LinkedIn if you want to have a chat, or if you see me around on the floor afterwards, please get in touch and I'm happy to talk. But I have one final request, and you'll have heard this before, but please rate this session, okay? And also, give me 5 stars. It makes a big difference to me, okay? So I want to see how many 5 stars I can get. But anyway, thank you very much. Appreciate it.